The purpose of this video is just to get you started on your concentration versus time station activity. I'm looking at station 1, question 1. So it gives me a reaction, and it says the initial concentration of SO2Cl2 was 0.0248. So I'm just going to kind of list what I'm given. Concentration of SO2Cl2 initial, so that means at time 0 is equal to 0.0248 big M, or moles per liter. It says the rate constant, so that's a K, is equal to 2.2 times 10 to the negative fifth, 1 over seconds. And it wants to figure out the concentration of SO2Cl2 at 4.5 hours. Now we're missing information here. We need to be given the order of SO2Cl2, and it is first order. So that tells me the y equals mx plus b equation that I should be using. All right, remember the first order reaction has a linear relationship when I graph the natural log of A versus time. So that means when I write my y equals mx plus b equation, on the y-axis I have the natural log of A at time t, which is equal to my slope, that's my constant, negative k. X is going to be time, plus my y-intercept, which will be the natural log of A at time 0. Now, had this been a second order reaction, recall that my linear relationship is going to be different. It's 1 over the concentration versus time. So I would be using a different y equals mx plus b equation. That is absolutely vital in this type of question. You need to first start with our y equals mx plus b equation. So if it's first order, you're using the natural log. Please look in your kinetic section of your reference tables. The first equation under there is the natural log one. So I remember first equation, first order. The second equation is this 1 over the concentration at time t is equal to kt plus 1 over the concentration of A at time 0. Second formula for second order. All right. Unfortunately, 0 order is not there, but I remember 0 is done to the A concentration. So it's simply for 0 order, the concentration of A at time t is equal to negative kt plus the concentration of A at time 0. Since I'm starting with a first order reaction again, I'm using the ln of A at time t is equal to negative kt plus the natural log of A at time 0. So what do I know? Well, I know I'm trying to solve for my natural log of SO2Cl2, right? That's my A. So I'm trying to solve to the left of my equal sign. I know my K, I know my T, and I know my original. I do have to be careful of my units. My K is in 1 over seconds, and my time is 4.5 hours. So I'm going to want to get rid of my hours. I know 1 hour is 60 minutes, and I know 1 minute is 60 seconds, right? I ultimately want to convert to seconds. So I'm going to plug this into my calculator, and I am going to get 16,200 seconds. Now I have enough information to plug in. Now I realize this is not how your y equals mx plus b is written on your reference tables. The A is brought over, the A at time 0 is brought over to the left side. Same thing with our second order reaction. This is my preference to start off with the y equals mx plus b. You don't have to. But again, I don't know the concentration of SO2Cl2 at my 16,200 seconds. By the way, this does nothing mathematically to the problem. It just lets me differentiate the A at time t versus the original concentration of A. I know my constant is negative 2.2 times 10 to the negative fifth. Very common to forget that negative sign. 1 over seconds. And I know my time is going to be 16,200. Again, you'll notice my seconds cross out. That's why it was important that I converted my hours to seconds. And I'm adding to that the natural log of my initial concentration. So my initial concentration is 0.0248 big M. So I'm going to go ahead and plug this into my calculator. So I have negative 2.2 times 10 to the negative fifth times 16,200. And to that, I am going to add the natural log of 0.0248. And when I do so, I am going to get the natural log of SO2Cl2 is equal to negative 4.05. And again, this is going to be a big M. They're not going to cancel just the seconds. So as you can imagine, I can't have a negative concentration. That doesn't make sense. And I do have to get rid of this natural log. So you're going to do the bed shuffle or the loop-de-loop, whatever your math teacher calls it. You know, I call it the antilog. So the LOG, the antilog, was to do 10 to the. In this case, we're going to use the base of the natural log, which is e. So e to the natural log cancels out. And then I'm going to do the same to the other side. So I'm going to get the concentration of SO2Cl2 is equal to e to the negative 4.05. So I'm going to plug that into my calculator. You're going to do second natural log to get the e, and then just negative 4.05. And that is going to give me my answer, which is going to be 0.017 big M. Now, had this been a second order reaction, again, I would have started off with a different y equals mx plus b equation. However, I would have plugged in everything into the equation. Oops, my seconds, just like we did with the first order reaction. All right, I would obviously get a different answer, however, because that reactant is going to be consumed at a different rate. I hope that helps as you are trying to answer the Station 1 and Station 2 questions. However, if it does not, make sure you ask me in class next time we meet.